Good morning, students. The topic of today's discussion is heuristic search methods. Before beginning the topic, let us discuss why heuristics, what is the need, and what are the advantages we achieve. In common English term, heuristics could be translated as an estimate or a guess made. What is the need of heuristics could be better understood when we know without heuristics what is the problem. Let us look at 8 puzzle problem. Puzzle problem has a start state. Start state could be in this manner 1 2 3. This is empty tile, and 4 6 7 5 8. Goal state. Goal state is 1 2 3 4 5 6 7 8 empty type. And then because here there are 8 numbers and you have to arrange them in the specified configuration. To solve this problem, we have got operators or actions that are 4 in number: up, down, left, right. What do you mean by operators? Well, it means moving empty tile to up, to left, right, or down. If you move this empty tile from this position to upward position, then it is apparent that we are applying up operator. All right. And then we know that our state space would comprises of various states that that we follow from start to reach the goal. For instance, if empty tile is at this position, second row and first column, we have 3 moves. From here we get 3 moves, and from the successor of the start node we get further successors. That is state space, collection of all the states. This is one state, this is another state, this is start state, and this one is goal state. And in between start and goal state you have several other states. All together are called as state space. And the AI system which we develop in order to solve various AI problems could be called as an agent. Okay. From today onwards, I'll be saying agent. Agent is the one which is a AI program or AI system uh, that can arrive to a solution given a problem. Let us begin. We will follow here breadth first search. Before moving into breadth first search, quickly let us reiterate what does it means. Breadth first search is performed at level wise, level order, or breadth wise, or breadth order. If this is the tree given, you start with the root and start like this. Take its first, expand its first successor, expand its second successor, further go to the first successor of left child, expand it, expand, it's like expanding the first successor, left child, then right child, then children of right successor. Further we explore in this manner. So this process continues. It is exploring all the nodes that are there in the tree, exploring all nodes in level wise fashion. This is our BFS. When we begin the solution to this 8 puzzle problem, we start with the starting state, which is 1, 2, 3, empty, 4, 6, 7, 5, 8. From here, we have 3 successes that could be generated based on the operator that could be applied to this empty. Because it is at the cornermost, we can apply 3 operators on this. Up, when it is moved up, it is empty 2, 3, 1, 4, 6, 7, 5, 8. When we take it down, it would be 1, 2, 3, 7, 4, 6, empty 5, 8. When we move it to right, it is 1, 2, 3, 4, empty 6, 7, 5, 8. One level is completed. All right. And then what has to be done? In the next level, we have to explore all the options of this node, second node, and third node. Here, how many moves is possible? This is right and down. Only we get 2 moves, R and D. Here, how many moves are possible? This is up and right. So up, right. These are 2 moves. Here, how many moves we could get? Here we could get up, down, left, right. 4 moves. If you expand this, you please expand, students, please expand this. I mean the first successor, second successor. I am expanding the third successor, but you please expand second and first and second as well. This is up. Uh, when you take it up, it would be 1, uh, 1 empty, 3, 4, 2, 6, 7, 5, 8. Down, it is 1, 2, 3, 4, 5, 6, 7, empty 8. Left, 1, 2, 3, empty 4, 6, 7, 5, 8. Right, 1, 2, 3, 4, 6, empty, 7, 5, 8. In this, if actually I am expanding this to arrive to a solution quickly. and to explain you the gist of having heuristics. But then you please expand every possible node so you can understand it better. When we look at the first successor, there are three moves possible. Here there are three moves possible. Out of these three moves, one is the solution. Here also three. Here three. If I expand this, you please expand all. I'm expanding only this. This one up, left and right. When we take the empty cell to the right, we arrive to the solution. 1, 2, 3, 4, 5, 6, 7, 8, empty. But this is not direct approach what I showed to you. It is going through and exploring every node in the level order. When we consider what will be its time complexity and space complexity, if you know time complexity, one of you can tell me what is it. Time and space, these are two important parameters that could evaluate and state whether an algorithm or a solution is feasible or not. If I give you assignment and if you take 2 years to write the assignment, uh, is it useful for you and will you obtain marks? No. Why? Well, because there is a time frame. There is a semester, there are some weeks, 15 weeks, 16 weeks, and last date would be specified. You have to submit your assignment on the given date, on or before the given date. If you don't follow that schedule, you miss your marks. So time is very important. What about space? Space is also very important with respect to computer. A computer would have limited space. You would have 8 GB RAM, 16 GB RAM, max. At the max, you would have 32 GB RAM. Even there are 4 GB RAMs. And then if the solution requires 100 GB, is that solution worth considering? The answer straight away is no. Why? Well, because what is the meaning of having a 100 GB solution when you can't fit it in our space, which is our RAM? Therefore, time and space complexity has to be assessed for every algorithm. That's why you are learning a very important subject known as DA. In this subject, for every algorithm, you have to compute or you have to solve, obtain the time and space complexity to compare the algorithms and to state which algorithm is better than the other. What is the time complexity of 8 puzzle problem when you solve it through breadth first search? It would be big O b to the power of d, where b is the branching factor, d is the depth. Branching factor and d is depth. What is this and how to obtain this big O b to the power of d? For that, please understand that how many moves are possible. First, let us understand branching factor. Branching factor is about how many nodes could be generated from each node. How many nodes we can generate from each node? Here we see we could generate 3. This is 1, 2 and 3. There are 3 successors for this node. And for first successor there are 2 successors further. Likewise for second there are 2. For third there are 4. And each one in the third successor could generate further 3 more successes. How do we know, and how many or on an average how many we could generate? To obtain that value we have to understand this. This is our board, 8 puzzle board. There are 9 tiles or 9 spaces, and it depends on the empty tile where it is placed in this 3 by 3 board, which are having totally 9 slots. How many moves or how many nodes could be generated? If the empty tile is here, center, if it is at center, then we get 4. 4 moves are possible: up, down, left, right. So one for one space it is 4 moves. And then if it is at in the corners, um, I am using here small circles. If small circles, these small circles are the empty tile. If the empty tile is at these edges, how many are possible? 1, 2, 2 are possible. This is right and down. This is left and down. So it is plus 2 into 4. And then next is, if the empty tile is uh, star here at these places, it would be plus. Here there are 3 moves possible: up, left, right. Here if it is at the third column, second row, left, up, down. So 3 into 4. And totally how many tiles are there? 9. So this is equal to 4 plus 8 plus 12 by 9, which is equal to 24 plus but 24 by 9, um, which gives us 9 to 18, 2 point some value. Okay, and that you are making it to you are using the highest value of this point, whatever you get. If you take the floor, not sorry, not floor, top, if you take the top of it, then it would be 3. So on average the branching factor for this 8 puzzle problem is 3. Okay, on average you get 3 nodes for each node. It's not same, it depends on the position. And when you solve like this by using different position values, you obtain 3. And that is the branching factor. If this is equal to 3 to the power depth, how much depth we can generate if you solve 8 puzzle problem. If you fully explore, then we could get up to 20 depth. 20 depth means what? This is node 1, this is successor 1, successor 2, 3, 4, 5, and so on up to 20. This is dot dot dot, this is up to 20. So up to 20 depth we can explore if we exhaustively solve this. Exhaustive or uninformed. If you explore all the options available, this is a very big number. Okay, where you get some number 3 to the power of 20, which is a very large and huge number. So many options, if you explore, it takes more time and more space. One more analogy, if I give you about the time and space complexity for finding a place. If you would like to find a place, you are a these days people are generating vlogs, and they go to various places, they move around the city, various eateries, and they eat from there and they give their reviews. That person is there, he want to travel. Suppose you are that person, you as a hobby you do that. From one place, if you have to go to another place, place 1 to place 2, and you totally don't know, don't have any idea about how to go there, if you have to explore. And first first time you explore one route, second time you explore another route, third time you explore another route, and you find out that the first route was the largest route. It requires more time and more your space. Yeah, you traveled more space. Later, once you explore all the routes, you find the shortest route. uh, if it is the longest, another second time you might go to second longest. Like that, you eventually know the shortest route. If someone else asks you, your friend, even he want to start this, if he asks you directly, you can say that p1 means person 1, uh, or blogger 1. If blogger 2 can get right information from blogger 1. And what is that information? It would be like a heuristic. Because blogger 1 know the heuristic, blogger 1 need not explore all the options available, he can directly find the shortest route because of this heuristic. However, having said that, there is one problem also. If suppose this blogger 1 is making a prank with blogger 2 and does not give the right shortest path and give the longest route, then what happens? Even then the heuristic does not help blogger 2. Remember, always heuristics will not help. 99% of the time it helps, but suppose 1% of the time, if heuristic is not designed properly, if the estimate is not right, in that case, uh, even we have to explore 3 to the power of 20 options with heuristics. But 99, even 99.9% of the time, I can say it gives the good route. And remember, heuristics does not give you the best route. This is a small example and a trivial case where perhaps it is the best, but then it is not best. Always it is not best. It is good. It gives us good results, but not best results. Whereas here we get the best results. When you use breadth first search, or this we looked at another option also where we get a optimal value in uninformed search. But then the best one is bfs, that gives optimal, that is known as optimal result. Optimal result means the best result. But to get the best, you can't spend so much of time and space. You have to go for the other method of solving the problems, which is heuristic search technique. Let us look at that. How does it work? Heuristic method or heuristic technique employs or leverages an estimate or a guess, a value. This value is uh, mostly takes you to the solution step closer in every step, and you don't have to explore all the options. Takes to solution quickly, a value that takes to the solution quickly. Again, consider the same 8 puzzle problem. In this 8 puzzle problem, if we consider the heuristics as number of miss h value is equal to number of misplaced tiles. uh, Same start and goal state. Start state is 1 2 3 empty 4 6 7 5 8. This is S means start state. Goal state is 1 2 3 4 5 6 7 8 empty. This is goal G. All right. uh, we start with this 1 2 3 empty 4 6 7 5 8. We will find the heuristics for this state. H of start state is H of S is equal to how many tiles are misplaced. One, compare this with the goal state. One is placed correctly, two is placed correctly, three also. Don't consider empty tile, consider only the values, numbers. Four is misplaced, so one. Six is correctly placed, seven is correctly placed, five, 4, comma 5. 5 is not placed correctly, 4 wrong, 5 wrong. 8 is also not placed correctly, comma 8, which is equal to 3. Heuristic value is 3. From here, here heuristic value does not give any uh, significant change for the first state. You have to explore all. Same up, down, and right. Up is 1 2 3, no, not 1, empty 2 3, 1 4 6 7 5 8. Down is 1 2 3. Simultaneously you also do, students. It's taking a lot of time, right, for me to do all this. Instead of just listening, do it in your notes. 1 2 3 7 7 4 6 empty 5 8. Right is 1 2 3 4 empty 6 758. Solve the. Will anyone tell me the heuristic h of S1? This is successor one. S1, S2, S3. Anyone please tell me the heuristic values for the three successors? Here, what is h? H of
One, ma'am.
h of S1 is 1. Is it 1?
Yes, ma'am.
No. Heuristic value means total tiles misplaced. Only one tile is misplaced here.
No, ma'am. 1, 4, then 5,
1,
then 8,
4, 5,
Five.
then 8.
8. So totally 4 tiles are misplaced. So h of S1. S1 is what? Successor 1. The heuristic value of S1 is 4. Heuristic value of S2 is 1, 2, 3. This is 7, 4, 6, 5, 8 is equal to 4. All of you got 4 for this? H of S3 is equal to 1, 2, 3, 4, 6, 7,
5 and 8.
5,
5
8,
and 8 is equal to 2.
2.
Here comes the significance of heuristics. Can anyone tell me what is now how heuristic plays a role? What does heuristic does here? What is the significance of this 442? If it is BFS, breadth first search, are we taking any heuristic value into consideration while expanding? Well, the answer is no. Because after you expand this start node, expand uh, first successor S1, expand all, get all the nodes of first successor. In the second step, expand S2, obtain all the nodes for S2, and in the third step, expand S3 and get all the nodes of S3. This is how BFS operates, which is a uninformed search, uninformed or exhaustive or blind search. Now we are learning informed search, which is the types we will discuss, but here uh, we are using heuristic. Heuristics is about having some information, therefore it is said to be informed search. Because it is informed search, now we will not explore this route, this route. Why? Because the least value among all the heuristics of these successors is 2, and we know that only 2 tiles are misplaced, therefore it is very is there any hand raise? I got the beep. Here we can know that uh, there are only 2 tiles misplaced, and therefore very quick to arrive to the solution. We explored this. How many options are there? There are 3. three operators that could be applied. This could be left, no, four. Up, down, left, right. I think this down one will take us to 1, 2, 3, 4, 5, 6, 7, empty, 8. Like this, we get configuration for up, left, and right. Students, please do for, please tell me quickly for up. Any one of you? If we move this empty tile upwards, what happens? What do we get? 1, empty, 3, 4, 2, 6, 7, 5, 8. Left 1, 2, 3, empty 4, 6, 7, 5, 8. Right 1, 2, 3, 4, 6, empty 7, 5, 8. And when we calculate the heuristic for S31, S32, S33, S34, compute the heuristics. What is H of S31? How many are uh, uh, how many tiles are misplaced? Just tell me the number.
4,
4.
2, 5, 8.
4. This is H of, okay, you told me 4, 2, 5, 8. Totally 4. Heuristic value is 4. What is the heuristic value for this? 1, 2, 3, 4, 5, 6.
1.
1. Heuristic value for S33 is 1, 2, 3. 1, 2, 3. 3. Heuristic value for S34 1, 2, 3. 1, 2, 3. 3. Among these four, which is the minimum heuristic value or lowest heuristic value? It is giving by S32 successor. Therefore, what we have to do? We have to explore this. To explore this, we have three operators: up, left, right. If you move to right, 1, 2, 3, 4, 5, 6, 7, 8, empty. Up means 1, 2, 3, 4, empty, 6, 7, 5, 8. Left is 1, 2, 3, 4, 5, 6, empty, 7, 8. Yeah, after exploring, we know that we have obtained the solution. Our goal node is reached, which is 1, 2, 3, 4, 5, 6, 7, 8 empty cell or empty tile. How many nodes we have explored? We have explored very few nodes. If you count, it is 1, 2, 3, 3. Only 3 nodes. We explored 3 nodes, means explored in the sense expanded. We have expanded 3 nodes and we obtained the solution. That is not the case in BFS. Why? Because in BFS, we have to expand 1, 2, 3, 4. Then from here we have to start. 4, 5, 6, 7, no, 5, 6, 7, 8, 9. Then 10, 11, 12, 13. Not 13. Yeah, all we have to explore 13. Then 12th node, to get to 12th node, again we have to start from S11, S12. Do you understand the difference, students? Because we are not expanding these nodes, we are arriving to the solution quickly. It is taking less time and less space. All right. Do you understand the difference between informed and uninformed search?
Yes, ma'am.
Yes, ma'am.
Very nice. We will begin with the informed search techniques. What are the uninformed search techniques? We learned four uninformed search techniques. Please, anyone list out? We looked at depth first search. We looked at breadth first search, depth first iterative deepening, and last one bidirectional search. These four methods belong to uninformed or exhaustive or blind search. Uninformed. We will today begin informed search. Tomorrow we will continue with that.
Ma'am, what we have done today, this is informed search,
Mm,
heuristic search.
yeah, both we discussed. We discussed uninformed and how we can use heuristic search. Uh, 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 Heuristic method. We used one kind of heuristic method here. Yeah, you can name this also one as one of the informed searches, but this is the basic search where we made use of one heuristic, and there is no single heuristic. You will get multiple heuristic to solve 8 puzzle problem. This is one heuristic method where we looked at number of misplaced tiles. We will look at other heuristics as well as we go along and study various informed or heuristic search techniques. Yeah, we looked at one method of heuristic, um, technique.
Okay.
Okay, we will begin now with another page where we will learn heuristic search techniques. There in that I gave you a intuition about heuristic search and non-heuristic search. Non-heuristic search we used a breadth first search and explored how things actually work. And also then we looked at one method of finding a heuristic value for every node and obtaining the solution quickly and uh, leveraging less space. Okay, that was totally about introducing the heuristic method. Heuristic search techniques.
And then heuristic search is much better than BFS and DFS.
I Please remember, heuristic search means it is like a common name given to all the methods. Obviously heuristic search is better, but there is one problem which I told you in heuristic search, which is negligible. We can ignore it. You can just neglect that problem. What is that problem? The problem is we will not find the best solution, but we may find next to best. We may find good solutions, but we can't say that it is the ultimate. Okay, but in BFS we can say that it is the ultimate, and after that there is nothing good that can come, because there we are exploring all the routes. That's why we can find the best among all that is best among all. Here it is not like that. We are not exploring all the routes. So, for instance, here I can tell you that when we explored only the third successor S3 based on its heuristic value, there are chances, if heuristic value is not that good, there are chances that after we explore this, we may not find the solution quickly. There are, sometimes ways where you can get optimal solution from here, from S1, successor 1, and not successor 3. The best may reside at successor 1, but next to best may reside at successor 3. We are okay with next to best, suboptimal. Uh, but we don't want to invest more time and more space. And it's not possible also, it's not feasible every time to invest so much time. And suppose if you are trying to find a solution to a problem, and if that computation takes 1 year, why do we say that password should have a small letter, capital letter, and numbers, special characters? Why? Do you know the reason? Nowadays all websites have made a rule that your password must have combination of all these.
And that will make hackers. I mean, that won't be possible to hack your account.
How do they hack? Do you know how do they hack?
Combination, they use different combination
Yeah,
permutation.
yeah, yeah. They use different combination. Here also we are trying different combination. You see, this is also like hacking a solution. This is like a good hacking, ethical hacking kind of thing. You are. They also search. That is also searching. Suppose if your password is Nizam, then what do they do? They take alphabet. In that there are 26 characters, and they try to create various combinations, not manually. They write programs for that. And first combination they try, second combination they try, third combination, then like that they continue trying. This is like a normal search. Suppose if they know you, suppose if you know me, and you know about my likes and dislikes, and you know my birth date, my various details, then what you can do, you can create heuristic. What heuristic you can create? Suppose if you know my birthday, suppose if it is 90, suppose might be one of you will have, or somebody is or my, consider mine only, 11890. If this is my birthday, this can be treated as heuristic, and then you may try. Okay, she may use. And suppose if my favorite animal is uh, um, suppose peacock, then you may try peacock 90. This is like heuristic. All right. But if you use characters, means letters, small and big both, and uh, 26 plus so many special characters are there, and digits are 10, consider 50 special characters are there. Making a combination and trying to explore like this and coming to password is um, it will take years and years, for a program to break your password. That's why you should go for this. Time complexity and space complexity for a program for breaking of password may take 1 million years, sometimes 10 million years. That's why I told you to learn time and space complexity. I shared with you all the few videos and also that. And there is a very good article I'll share with you. You should know about time and space complexity, students, if you want to become developers and enter into software industry. Very essential thing. All right, it's like mandatory. That's the reason, um, you know um, but heuristic plays a vital role. Even, with all this, if suppose a person knows me very well, even then he may try, to break, and he maybe there is a possibility, 1% chance that he may break. But then there is a nowadays we have two-step verification. When you do two-step verification, if you try to log in, even if you break the password, if you try to log in, it asks you to allow from your phone. If you allow from your phone, only then you can enter in your inbox. This is more secure. All of you go for this two-step verification. All right, students, I think time up. Tomorrow we will begin the discussion of heuristic search techniques. Any doubts in today's class?